Hi, kids. Hey, we are perilously close to increasing our capacity to understand capacitors. We're going to do a problem where we have to solve for stuff. So, hey, let's pretend I have this circuit. First thing you need to be able to do is recognize, is it a series circuit? Is it a parallel circuit? Is it a combo circuit? In this case, it is a series circuit. How do you know? You can always, if you want to draw in your equipotential lines, hey, look, there's one equipotential line. Hey, look, here's the other equipotential line. Hey, look, each of those capacitors are touching the battery. That's a parallel circuit, okay? So, a parallel circuit. So I'm going to solve, again, what could I ask you? I could ask you things like, hey, what's the total charge stored in this circuit? What's the total energy stored in this circuit? What's the charge for this one? Or whatever it is, okay? So we'll go through how to solve stuff. I would recommend let's simplify it first. So remember in parallel, to find the total capacitance, you just add them. This was on your formula sheet. Whoops. CP equals the sum of C individuals, because the total capacitance in parallel is just add them up. So if I add those up, here's what I'm going to get. Because guess what? This plus this is 30. So if there is a question that says, hey, what is the total capacitance of the circuit? 30 microfarads. Okay. If there is a question that says, hey, what is the total charge for this circuit? Okay, so again, I always go back to my graph, QV. Oh yeah, C equals Q over V. Oh yeah, this is going to be this times this. Oh, that's going to be 300 microcoulombs of charge will be stored in that circuit. And then, oh yeah, the area of this graph is going to tell me the energy. That's going to be 1/2 Q times V. So if I wanted to do the total energy in this circuit, it would be 1/2 300 times 10. So if you do, that would be 1,500 microjoules. Okay, hopefully I did that right. Okay. All right, but you guys understand. So if there is a question that says, hey, what's the total energy stored in this circuit? The answer would be 1,500 microjoules of energy. If this was, hey, what's the total charge? It'd be that. And then you just work your way backwards, like we do. All right, so let's work our way backwards. So, hey, what did I simplify here to get to here? Oh, yeah, that was parallel. Remember, equipotential lines, so the voltage has to be the same. So what is the voltage here? Oh yeah, that has to be 10 volts. What is the voltage here? Oh yeah, that has to be 10 volts. And then you can just multiply this by this to get your energy, or the charge, sorry, which would be 200 microcoulombs, which would be 100 microcoulombs. And then if I add this plus this, I get this because it has to. There's 300 that comes out and then it splits. It doesn't split equally. This has more capacity to store energy and charge, so more charge goes that way and gets stored there. And then you can solve. Isn't that beautiful? I know. It is. I love physics. It's amazing. Bye, kids.